Hey everyone, and welcome to this introduction on machine learning. Today we'll first talk about what machine learning is and how it is somewhat similar to our brains, and we'll see some basics on how a machine learning model works by actually simulating a machine learning algorithm called linear regression. Machine learning is fundamental for several tools that we use in our daily life. When you use Google Translate, you're using some of the most sophisticated machine learning algorithms. When Netflix or Spotify is suggesting you a new movie or a new song, it has been using machine learning models to study your tastes and predict something you might like. The way it works is somewhat similar to how us, as human beings, learn from experiences. If I gave you a picture of this animal and ask you whether this is a dog or a cat, you probably only need to think about it for a second, right? Now, ask yourself, why are you able to say that the photo you saw was a dog? In your life, you've probably seen thousands of cats and dogs with several different features such as size, color, and fur. Throughout this process, you're able to abstract all these individual animals into a more generalized concept that is defined with the words dog and cat. In this way, every time you see a photo of a dog, even if you've never seen that particular dog before, you're able to see what animal it is. Now, keeping in mind what we just said about humans, let's try to build a machine learning model that simulates our learning experience. This model is called linear regression. As humans, we have several years while we grow up to see different animals, but for a machine, we can simulate that experience in a couple of seconds. I know, it's incredible, right? So let's just take several pictures of dogs and cats, and now we give these pictures to our model and ask the model to remember for each of them the weight and the size for each type of animal, as if we're simulating this model growing up from being a baby to, just a teenage and an adult, just in a couple of seconds of experiences. For today, let's just assume we have a fancy algorithm that is able to extract from a picture an approximation of the weight and the length of the animal. In this graph, you can see a yellow dot corresponding to each dog and a red dot for each cat. The x-axis represents the weight of the dog, while the y-axis represents the length. This is called the training phase. During this phase, the model is learning the different lengths and weights for cats and dogs. Lengths and weights are called the features of the model. They are extremely important because based on the features we choose, the accuracy of the model will change. In this case, we could have chosen other features, such as the color of the fur or even the height, but for sake of simplicity, we'll stick with 2. Now, let's take a look at the graph. We can see that the spatial positioning of the data we fed to the model is not randomly distributed. In other words, there is a space where the majority of the data are cats and a space where the majority of data are dogs. Let's call them the cat space and the dog space. The task for our model is to find those spaces and draw a line to separate them, trying to be as accurate as possible. As you can see, no matter what positioning the model tries, there are always going to be some cats in the dog space and some dogs in the cat space. The model will keep finding the best line, trying every time to minimize the number of errors. This is a very complicated task because it's hard for the model to know when it found the best possible line, or in other words, when it is time to stop. That is why models have a stopping condition, which simply is a condition that will make the model stop finding the best line once a certain minimal error has been reached. So, for example, we could stop if we only have 1 or 2 cats in the dog space or vice versa. Once the model has found the best line, we can move to the testing phase. We can feed the model a picture of a dog that it has never seen before, the same one I showed you at the beginning. The model will plot the data into the space, and based on where it is compared to the line, it will guess the type of the animal. What I've just shown you is an idea on how machine learning works. These models use several thousands of features and data points, and for this video we just simplified them to make it easier to visualize and to understand. As we mentioned, models are not perfect though. Our model in certain scenarios might not be entirely sure on whether a picture contains a cat or a dog, and it might make mistakes. This happens for the images that fall close to the dividing line, which is potentially cats that have a similar length and weight to dogs, or dogs that have a similar weight and length to cats, like this picture. In this case, our model predicted that it can be both a cat or a dog because you see it falls very close on the same line. But the real question is, can you actually tell whether this is a cat or a dog?